So for this chart, we're trying to determine whether it represents a function or not. I actually have two variations here because a couple of these problems, sometimes it is, sometimes it isn't. So let's get to the bottom of how we know which one is which. So remember, a function would be saying that every specific input needs to have a definite output. So for instance, the numbers 1 through 12, number of people attending 1 through 12, all get assigned to a 1, okay? So that's just how many tables are needed, okay? So if there's 1 to 12 people, you only need 1 table, okay? So if there's 11 people, you only need 1 table. What if it gets to, say, 13 people? Well, now 1 table is not enough. 13 people requires 2 tables. And that's the same all the way up to 14, 15, 16, all the way up to 24 people. That would accommodate with just 2 tables. And then 25 through 36 needs 3 tables. 37 through 48, 4 tables. 49 through 60, 5 tables. So it looks like we have a sequential pattern, 1 through 12, and then 13 through 24. See, the other one picks up right where the other one left off. So 1 to 12, what's next? 13. Oh, 13, yep. 24, what's next? 25, yep. Each one of those picks up. So this would be yes. This one is a function because any given number of people tells you how many tables you need. Let's look at the second one, though. 1 through 8. Okay, so in this case, there's 8 people per table would accommodate. So 1 to 8 would be 1 table. What's after 8? 9. Well, 9 through 16 needs 2 tables. What's after 16? 17. 17 through 24. What's after 24? 25. Uh-oh. Look at that. There's some overlap here. The 17 through 24 has an overlap of the 20 through 35. And also it looks like the same thing happens here as well because the 35 should be followed by 36, right? The next amount. So there's an overlap. In other words, if I say, how many tables do you need for 20 people? So F of 20, well, according to this chart, this would fall under either 3 tables or 4 tables. That is a problem for a function. So this would be no, not a function.